Welcome, everybody. This session is the basics and intro to programming. We are fortunate enough to have Danny Diaz, who is an engineer at First, and he's going to give an overview and configuration of the 2021 FTC Control System, including basic introduction to programming, a simple robot with blocks programming language, and it's really kind of intended for rookie or beginner level coaches using the Control Hub and the Driver Hub components. Is that correct, Danny?
That would be absolutely correct. Yes.
All right, I'm going to go ahead and turn it over to you. Thank you, Danny.
Yeah. All right. So I'm hoping that I am successfully sharing my screen now.
Yep, you got it. We can see it.
Hey, all right. And I'm apparently using the same template. I promise it's the same template, but different layouts. Apparently, my layouts are slightly different. But hey, I'm Danny Diaz. I'm the senior systems engineer for First Robotics Competition. And yeah, I'm here to talk about the robot control system and programming for beginners. And we're going to be using the blocks programming language here. But really quick here, the target audience for this, as Rebecca mentioned, is really beginner coaches and mentors, or anybody who wants a refresher on how to use blocks. I know my first couple of years, I enjoyed having a nice refresher. But and you need to have some basic level of mechanical knowledge, as in, okay, this is what a motor is and how to hook it up. This is how to build a simple chassis. You can look at a guide and pick up that little bit. Little bit of electronics, how to plug the wires in, how not to get shocked too much. And I'm not going to necessarily teach the basic levels of programming. I'm hoping that you've got some knowledge of ifs and whiles, and maybe a little bit of what a function is. I'm not going to cover that, and I'm hoping doing this. I'm not shooting myself in the foot here. This is really intended not for students, right? This is meant for a coach who wants to come in, learn about it, and then synthesize all of this for students. Now, I know for certain there's going to be some coaches who, will grab their high school kids and say, "Here, watch this." Great, okay, that's fine. But the type of student that I normally work with, which is the middle school, seventh and eighth graders, this would be way too much to just kind of toss them into. So I'm hoping you'll synthesize down some of this information for those who need it. All right, so some quick topics that we're going to cover. We're going to cover the Rev hardware client, the control hub. We're going to cover a little bit of the driver hub, because I've got a driver hub and I'm really in love with this thing. We're going to talk a little bit about robot configuration, blocks programming, and we're going to learn how to do, and that's a driver controlled programming, but we're also going to look at some autonomous programming and talk about some pitfalls that normally people go into that, maybe hopefully I can help you not have to get into it. All right. So yeah, here's some additional activities, very similar to the previous page. So let's dive into the FTC control system. And this, remember, this presentation is kind of designed for those who are kind of being thrust into this kind of at the very beginning. And so hopefully this will solidify some of your understanding. Um, your job, in the very beginning of being a mentor, is to help the students build a robot, and the robot is really composed of the Rev control hub, or if you've got a phone and an expansion hub, those two things go together. But from here on out, we're just going to say you're a rookie, you're buying a rookie kit. The rookie kit has the control hub, and the rookie kit has a driver hub inside of it. And so all the tutorials that I'm going to send you to, for really in-depth knowledge, has all of the if you've got this, or if you got this, or if you got that. But we're going to talk about the control hub and the driver hub. So the robot itself has the Rev control hub. Now, the Rev control hub is your brain for your robot. That's the thing that controls that your motors plug into, controls your motors. It gets data from your sensors. The Rev control hub actually has a Wi-Fi device on board, and actually broadcasts an SSID that other devices like your driver station equipment, which is your driver hub, or your laptop when you're programming with your laptop, all of those things will connect to your robot via Wi-Fi. Now, of course, the programming laptop, you can plug in a USB to it, no problem. But you're not going to be tethered when you're on the competition field, actually driving around. And then you've got this driver station entity. And the driver station is going to be your driver hub, your gamepads plugged into that driver hub, and any other structures that you have that help you out. When I came back into First Tech Challenge in 2014, uh, it was a mess for me because I just couldn't handle all these devices with cables hanging off of them, and it was just the for me when I walked away from not walked away, but I kind of stepped away from FTC a couple years previous. We were still on the old system before the phones came into play, and so all of the joysticks and everything was handled by the field. So I took a little bit of some of the design space from first robotics competition and kind of developed this little driver station. And all it really is just a place where you can store your Android device, which is in this case your driver hub, can also store your game pads and actually help the wire management with the game pads. This has been such a big help. Teams here in New Hampshire have kind of cloned it and actually done some really cool additions and some innovations to it. But just I recommend the very first thing you do is to just get a board and not nail your stuff to it, but try to make some sense out of the chaos that's going to be all the game pads and the wires and all the cabling and everything. The driver hub is going to help a lot this upcoming season because it gets rid of a USB hub that you used to have. But you really want to make sure that when you come up to the competition field, you're not trying to juggle wires with trying to juggle kids and juggle the robot as well. So your Rev Driver Hub is going to connect wirelessly via Wi-Fi to the robot, and that's what's going to actually send commands to your robot from the gamepads. All the communication is going on there. That's also how you configure your robot for programming. And then, of course, you'll program with your laptop, and your laptop will also connect up to the robot in order to upload and download programs to your robot. So there's a lot of software on your robot. And you're going to hear words being thrown around a lot. You're going to be talking about where are the robot log files? I need to see your log files to see what happened to your robot. You're going to be hearing about the IO configuration or the control hub configuration or the configuration files. How do you get access to that? And where does your robot program go if you change out your driver hub? Do you have to re-download all your programs? And then kind of what is the driver station app and where are your settings for where's your 5 gigahertz settings for your driver hub? And so this I'm hoping kind of helps put a little bit of this in perspective. This is from the perspective of where stuff is and what it's updated by and how it's updated. So the two main devices that we have here, we have the Rev Control Hub, and remember that's what goes on your robot. Okay, you got the Rev Control Hub, and then you've got the Rev Driver Hub. Now the Control Hub is where the vast majority of your robot settings and all settings are going to live. As long as your Control Hub doesn't go away, which it probably won't, then you don't ever have to really do much as far as reconfiguring the robot once it's configured. The driver hub is just a head. There's nothing really stored on it except some of your settings in order to be able to know which driver hub or which control hub to talk to. You're going to need a couple pieces of software, but the main one, the first one, is the Rev hardware client. So you can download the Rev hardware client, I think somewhere around here. Yep, here it is. So I have a link here where you can go and click on it and get the Rev Hardware Client. The Rev Hardware Client is where you're going to update most of the software on your two devices. Um, and honestly, uh, the Rev Hardware Client is what installs the FTC Driver Station app. So everything really comes from the Rev Hardware Client, except a browser that you'll use to actually program your robot. So literally that thing just does everything. And so you can plug your, thanks Manny, he put a link in the chat. You can plug all of your devices, your Rev Control Hub and your Rev Driver Hub up into your laptop, and then literally in the software you just click one button that says update everything, and it'll just go through and just literally update everything. And you just kind of go grab a coffee, come back, and everything's done. It's fantastic. And now, as of like one release ago, you can also view your robot log files. So if your system keeps cutting out in the middle of your match, or you're having a program that keeps crashing, there's probably something in the robot log file that'll tell you what's going on. And that used to be a big pain to try to figure out how to get access to that. And so the great guys at Rev went on ahead and said, you know what, this is a problem. Let's go ahead and fix that. And voila, there it is. So that's pretty awesome. So pretty much everything that you're going to deal with is that Rev hardware client. So the first thing that you really need to do is set up and configure your hardware. And what you'll need for that is, of course, your laptop with the Rev hardware client installed. There's the link for the Rev hardware client. You're going to need your control hub. You're going to need a charged robot battery and a power switch, because the control hub cannot be powered via USB. The driver hub can, and actually the driver hub charges on USB, which is really awesome. And then you get USB-C cables, these orange cables, with your hardware, and so you'll need to make sure you have those with you. So there's one USB-C cable per device, so there's two USB-C cables. And the very first thing I'm going to do is send you to the blocks tutorial. Now, the blocks tutorial isn't just the blocks programming language. It's literally everything from soup to nuts on how to, take um, uh, the hardware that you've got and actually configure it and program it. And I mean, just literally everything from basic blocks to using Vuforia. Just it's crazy, crazy put together. It's very thorough. I think there's a team of people who worked on this, and they were just fantastic. But when you are looking at the documentation, you will see that it'll talk about Android devices. If your Android device, well, the driver hub is your Android device. And there's two main sections that you'll want to take a look at in this first configuring your hardware. That's installing the FTC apps and pairing the driver station to the robot controller. And when you go there, you'll see and this is one of the pages here. Um, and then you'll also look at it. There's a section on configuring your hardware, and that's talking about creating a configuration file for the driver station. You're just going to follow those documentation there. Literally, it just walks you step by step on how to do it. I could do it here, but it would take 3 hours. Then we're going to try to create a blocks program. And the blocks program, when you're using blocks, and when you're using the control hub in general, you're going to hear the term op mode a lot. And really, op mode is short for an operational mode, and that's a program on your system. Now, in blocks, you don't have multiple files that make up a program, which really simplifies things a lot. And in other ways, it makes things a little bit more cluttered. But one file, one program is an op mode. And so there's two different classes of op modes, and that's an autonomous op mode. That's a program that runs your autonomous code on your robot. And then there's a TeleOp or driver controlled op mode. Now, what's kind of interesting is that there's really just one op mode to rule them all. An op mode is an op mode is an op mode. There's nothing special about an op mode. It's just what you do inside that op mode that actually does the actual work. And so what we've got is in blocks, and over here on your right hand side, from the tutorials that you previously have taken a look at, you will have seen your first glimpse of the blocks programming platform. Now, I don't know if I really stated this before, but Blocks is on robot. So there's no software you have to actually install on your laptop, which makes everything so much better. There's no software. You hit a web page that's actually being served up by the control hub, and you have access to program your robot. Um, a lot of people also like to use onbot Java, which is done the same way. Instead of having the Android Studio on your laptop and having to do the programming there on your laptop and then upload that to the system, and everything's just right there on the robot. You connect up, you make a change, you just say compile, and then there's no extra software you have to have on your laptop. You can literally use a Chromebook on for your programming. You may even be able to use a tablet if you have a mouse. The whole click and drag thing doesn't work so well with blocks. But when you're creating an op mode, because op modes are universal, remember that, you actually tag your op mode as being a TeleOp op mode or an autonomous op mode. And literally all that is what list it puts it on. When you look at your driver station application, which hopefully you will have looked at by the time you got here, here's a snippet of what the driver station application looks like. There's these two arrows, and in the middle it says autonomous with an arrow going that way, and then teleop with an arrow going that way. And so when you click on one of these, this arrow here on the right hand side, you'll get a drop down of all of the programs that have been labeled a teleop program. And over here on the left hand side, you'll get a drop down of all the ones for the autonomous program. And that's great for competition where you have to say, all right, I'm stepping up to the station and I need to run an autonomous program and I need to select that autonomous program. Or I need to now, I just want to run my teleop program. And so then you select your teleop programs. But as far as blocks is concerned, an op mode is an op mode is an op mode. It's just what area it goes to. There's a question here about, is this the same display on the new driver hub? Yes, it's the exact same application. The application actually has some extra bells and whistles. Like, I had never played with it. Apparently you can do it on a phone too, but you can take it and put it in landscape mode, and landscape mode is so awesome on the driver hub. But yeah, it's the exact same environment, the same look and feel that you have on the phone and the driver hub. It's just the driver hub isn't controlled by a third party who may, accidentally drop support for your phone for us. And so at least we know that the driver or the driver hub will continue to be supported, and you can buy more driver hubs versus the phones are kind of becoming slim pickings and finding one that works.
Another Easter egg on the driver's display is when you turn it landscape, you can also pull up a clock, the 2-minute and 30-second clock for running your match if you wanted to time
that. Right. Yeah. Thanks, man. Yeah, you're right. All right. So I want to talk a little bit about an op mode and program flow. So you've got, and I apologize for the level of granularity of this image here. It was very difficult for me to get images off of the driver hub because I didn't connect it up to my home Wi-Fi yet. Everything was just, like I would do it at a competition. I wanted to do that, and I just haven't actually connected it up to my home Wi-Fi. And so getting images off of it is kind of difficult.
It looks fine, Danny. Go ahead.
Okay, excellent. All right. So I wanted to show what the driver station looked like. And so I just took a picture of it, the driver hub, the driver station application, and the program that you write, the blocks program that you write, and this is just a sample blocks program. It's literally one of the samples that we have. It's the tank drive sample, and then a program flow that talks about how the programming actually works. So the very first step to all of this, your robot is on the field. You turned your robot on. Your driver station is there at your driver station area. You've turned it on. You've got this, your robot, your driver station is connected to your robot. Now what happens? And understanding this process flow really helps you understand the software and what you have to do when and where and how. So the very first thing that happens in this program flow is on the driver station application. And so it goes, it's literally serial, driver station, robot controller, driver station, robot controller. The user will select a program. Remember, we talked about the two arrows, the arrow on the left-hand side being the autonomous and the arrow on the right-hand side being the TeleOp. You'll literally tap that arrow and then it'll come up with a list of programs that were labeled TeleOp or autonomous. And so you will select the program that you want to run. Regardless of whether you're running autonomous or TeleOp, this all works the same way. And then the user would then press the init button when they are ready to initialize their program. Now, this doesn't mean that the robot should start driving across the field. This just means that we're ready to initialize the program. And when you press init, then it changes to start. So that if you press the start button, then it's ready. But at this point, you've pressed the init button. So what happens on the robot? So on the robot, it actually executes the run op mode function. Now this is a standard function name that you can't change. You can't change this. This is the landing point into your code. Whatever you got in here will actually start running from the top down. Everything goes from the top down. The blue block here with this comment in it, this is literally just a comment. There's nothing else there except for it telling me just a little bit of information about what's going on. And the code will keep executing until it hits wait for start. That's this line right here. So I've got a 1 pointing to, hey, we're going to run until we hit wait for start. And so it's going to execute this line right here, where it looks like the right side drivetrain, we're changing the direction to reverse. And we can talk about why that is. And if you've got two motors and you rotate one of them around, then one of them's rotating clockwise, but the other one's rotating counterclockwise. And so if you actually just tell your robot to go forward, it'll actually just spin around in circles. And so you logically change the direction of one of the motors. And if you get it wrong, which one, I mean, yeah, your robot will then just go backwards. So then just change which motor is backwards. But if you logically change it, then later on in your code, all you have to do is just say, hey, go forward, tell the motors to go forward, and your robot goes forward. So that's pretty cool. So we're going to hit the wait for start, and then wait for start stops. Then that's waiting for the start button to be pressed. Remember, init turns into start. Okay. Then when the match is ready to start and the referee gives their initial 3, 2, 1, go, then the driver will press the start button. And once the start button gets pressed, then the program resumes at wait for start. So it will start executing from this point. The function call returns, and we start executing more code. Now, from this point on, after we press start, the op mode is active is true. Now, this is a very important thing because these two things, the driver station and the robot, are operating independently of one another. If you stop the program on the driver station side, the robot doesn't know it unless the robot asks, hey, are you still running? And so if nothing ever looks to see whether or not the driver station is still saying go, then the robot's just going to keep going. And if you have to stop the program quickly, or you have an emergency and have to stop the program, or the match is over with and I'm going to stop the program, the robot actually won't stop. So we have to, in our code, we have to call and make sure that op mode is still active. And so we're at the when we come back out of wait for start, we're just making sure that we didn't miss, somebody pressing the stop button. And so we check to make sure that everything is active. And remember, from this point on, until later, it's going to be true. So we're saying if op mode is active, so we're still running, everything's good. Then we execute code, and we'll keep executing code. And op mode is active, we'll keep returning true, but we'll keep executing this code inside of this repeat loop. Notice that the only thing that's going to stop this repeat loop from executing is op mode is active not to be true. And so the robot's just going to keep doing whatever it's doing, whether it's great or not. It's just going to keep going until the user presses the stop button, and this button just keeps getting overloaded with, the init, the play, or start, the stop. And so the user then presses the stop button, and then op mode is active returns false. And so when that returns false, once it comes back to the top of the loop, it says, oh, we're not active anymore. And then it drops out and the code finishes and we're done. The robot stops. Well, the robot stops if we've told it to stop, and hopefully we have told it to stop.
Danny, given the fact that you only are running the repeat loop inside that if, do you really need the if?
So that's actually a really good question. Do we really need the if? And the answer here is no. You don't really need the if here. There is this comment here about put run blocks here, and there's also a way of thinking. It's a mindset that before you do anything, almost anything in a function, you should always check to see if op mode is active. It'll make more sense when we go to write our own functions, which I will show you an example of in a little bit. But you should always do this check. And you should always train yourself to do this check. And so, yeah, it's just one of those things that will make sense in a little bit.
Okay, thank you.
Yeah. So I also wanted to show you how this works with autonomous code. Now, in autonomous code, there's two things that we don't really have. Actually, there's a couple things that we don't really have. We don't have this repeat loop, but we also don't have gamepad support. So in autonomous, we're not playing with our gamepad, so I can't get data from the gamepad, and we typically don't have this repeat loop because we're trying to execute a series of things, and you're usually only trying to execute them once. And so here I have relatively the same code. I'm setting my my motor to, my right motor to be backwards so that I can drive forwards. And then I have an if do here, okay, that says if the op mode is active, then carry on and perform these autonomous actions. And so in this particular code, there's a couple of functions that aren't being shown here just to keep things kind of nice and tidy. And what happens, we're in the run op mode. We press, we select this autonomous, we press init. And so then the init actions happen, which is setting the direction. Now, if we had like servos and things that needed to pull in order to be within our size constraint, you could do that here as well. And then the code begins execution up to, in run op mode, up to wait for start. And so then we stop at wait for start, which is, where this one is. And then we press the start button on the driver station, and then we just keep doing things. And we are going to resume from wait to start, and then op mode is active is always going to return true. So this op mode is active is going to return true. And so then we start executing our autonomous code. Now, these are what are known as function blocks. Okay. Now, this function block can be used as many times as we want. Doesn't matter if it's in TeleOp or in autonomous. We can use the and we can do it multiple times here in autonomous, multiple times in TeleOp. And so we're going to call move forward with distance. So this is a function that I just said, you know what, drive forward for a certain distance. And so this calls the move forward with distance. And this checks if op mode is active, then do the actual thing that uses an encoder. And I just sort of hid the details behind another function there. The important thing is if I stop the program, okay, if I stop the program in between checking if op mode is active and calling this first function, then I would not execute anything inside of this if the op mode is no longer active. Now, this particular op mode, let's say you're driving 12 feet across the field, your robot is going to drive 12 feet across the field before being able to check if the op mode is active again. And so you don't want to be in the situation where you press the stop button and your robot doesn't know that you should be stopping. So you should be checking anytime you have something that waits a while, and then anything you do after waiting a while, you should always find out if the op mode is active. And that's something you're also going to have to train yourself, is constantly checking whether or not the op mode is active. And so at the beginning of every function, we check to see if op mode is active. Because if we stop the op mode in the middle of doing this operation here, then we don't want to execute this turn and we don't want to execute going forward again. We want to just fall through and not do any of that and finish the program and just, have the robot stop. And that's the goal here, is to say, if you stop the op mode, everything just falls through. And so if you just take, in your mind, the mindset of at the beginning of every function that you do the if op mode is active, and you'll always have something that you'll almost always have something that falls through nicely. And it'll make a lot more sense once you start getting a little more practiced with programming, either in blocks or in Java or on bot Java. Okay. So let's talk a little bit about, let's sort of recap what we learned here, right? Here in our code, we have program checkpoints. And so here are the checkpoints in our program. The first checkpoint is where the program starts, right? We start the program in run op mode. No other function runs first other than run op mode. And then we have a checkpoint at call wait for start, right? Call wait for start is a checkpoint. We also have a checkpoint at op mode is active. And anywhere we have op mode is active, it's going to come back and check to find out whether the op mode is active. We also have a configuration area. When you initialize your program, there's an area that is going to execute, and that's going to be in between run op mode and when you have wait for start. That is your initialization area. That's where your initialization code goes. And so the only thing that we're doing here is just changing the direction. Now that could have been done down here where it says put run blocks here, but again, this is another mindset thing that you sort of put yourself into. And then there's autonomous. Well, here we don't have any autonomous code because this is labeled as a TeleOp program. So we don't really have any autonomous code here. Now, you can still have actions that are autonomous, like, that let's say you press, a button on your joystick and you want your robot to, drive 3 feet straight, turn left, and then drive 3 feet straight, again. You can do that, and you could have autonomous or semi-autonomous actions. And then we have our TeleOp or driver controlled code, the code that will execute in driver controlled until we say we're done. And the same thing inside of your autonomous code, you've got the same checkpoints. You've got checkpoints at the beginning of every function. You got the wait for start, and then the beginning of your actual autonomous. Same thing, we've got initialization, our initialization here at the top. We've got our actual autonomous code. Now notice I don't label these as autonomous code because these are functions. These functions could be called in any mode whatsoever. But what's really important is the autonomous actions that you're taking, the sequence of autonomous actions that you're trying to get your program to do. And then we don't really have any dedicated teleop, so there's no teleop here. All right, so creating a blocks program. When you go to create your blocks program at the very beginning, you have to decide for yourself, do I want to create a blank op mode? You know, that's an op mode that doesn't really have any structure to it. You can do whatever you want in this blank op mode. Or do I want to use a sample as my starting point? Now there's lots of samples that we have, and the samples are great for creating new code, for learning new code, and for starting your program off. I almost never start with a blank program. I always start with an example. And the basic tank drive is actually a pretty darn good example to actually start with. And by tank drive, I mean taking two sticks, and you push them forward and the robot goes forward, and it's a skid steer using two sticks. One stick controls the right hand side and another stick controls the left hand side. There's a question here about, can you create an import library in blocks so that methods can be used in both teleop and autonomous? I wish. Remember I mentioned in blocks, there's one program, one file to rule them all. You actually technically cannot import code that way.
There's no add include directive.
There's no add include, right? There's no, hey, I want to take this file and just put a bunch of stuff, a library stuff in it. So everything is right there. But Liz Looney, who's like the Google Blockly brilliant person ever here, that we, fantastic volunteer. She's been volunteering with us forever. She actually has a way to do that for some things, and I'm hoping that when she develops it a little bit more, we can do this where we have potentially import library. You can create import libraries and call into those import libraries. I know that she was working on that to be able to share code between Java code and blocks code. But then if users can create them, then you could create your own import libraries or your own support libraries that would have things that you want. So that's something
that'd be cool.
Is coming down the pike. And it makes me really excited and really happy. But yeah, it's coming, but it's not quite there yet. Sorry. But I like the way you're thinking. Okay. So I want to talk a little bit about what this basic tank drive. So I came in and I said, I want to use the tank drive code, the sample. So I want to understand what the sample is doing. So clearly we've seen this, we've kind of talked about it a little bit. And so let's talk about what it's actually doing. The very first line here, coming in when you start the program, the very first line is flip the direction of the motor. That's your initialization code. Fantastic. We know what that does. Then we have, the wait for start. We know what wait for start is. We have our call for is op mode active. Okay, we know what that is. It's in our head. We know what it is. We have a repeat here. This is going to keep looping. It's going to come in and do something over and over and over again, which is fantastic. And it's going to always check to see if we're still active. Great. And then we have a block here. And this is where you can go to, there's a tutorial for everything. The tutorial that I'm about to send you to will show you these blocks. This is a dual motor block, so you can control two motors at the same time. You can only control up to two at a time. You can do one by itself or two by themselves, or yeah, two together. And so this is just setting the power of the motors together. But what we're doing is we're getting the value of the game pads. So one of the things that you'll kind of learn is that the joysticks have a value when they're all the way up. It's like a value of +1, and all the way down it's -1, or vice versa. Yeah, a flip. I always get it wrong and then have to come in and throw negatives all over the place, which is what kind of is done here. And then I'm taking those values and I'm piping them right back into the motor drivetrain, because the drivetrain takes a value from -1 to 1. Negative meaning go backwards, and then positive meaning go forwards. And so if I just take those joystick values and pump them into the motors do what my joysticks are doing. And then I do telemetry, and telemetry is just a cool way to take data from the robot and send it back to the driver station and print out on the driver station window to say, hey, here's what my drivetrain power is. Because it's nice to be able to use your joysticks and then know that your robot, if your robot's not doing anything, it's nice to know that your robot is either getting data or not getting data. And then you can look for, an electrical problem on your robot versus a programming problem on your in the system. So telemetry is really nice. There's a great tutorial that talks about telemetry, and that's here. So running your op mode. And so this is a great step-by-step instruction on how to just set up your op mode and do everything you want to do with your op mode. How to configure your joysticks to be able to run your op mode. How to literally everything, step by step, how to run your op mode. Again, the guys who developed this wiki, probably Tom and Chris, they were amazing. And then I want to do one final plug here. I'm pretty much out of time here, but I got a final plug for the simulator that First Robotics Canada has developed. It's based on a tool chain called the PixelPad tool chain. This simulator is the best thing since sliced bread, at least right now. The problem with blocks and all of the awesome things that run on the robot is if you don't have a robot in front of you. I've got like 7 people on one of my FTC team, my middle school FTC teams. I got 2 of them, but I've got 7 programmers. No, I have 4 programmers out of the 7 people, and I don't have 4 robots, 4 control hubs to be able to hand out and let the kids, program and then try some stuff out, see what happens, see what doesn't happen, break things, make things do whatever. And you can't. I mean, you can't even do that with Java, right? You can't test your robot stuff, but you could write little hello world things, with Java, but you can't actually test to see what a robot will do with your code. However, with this simulator, you can. Now, it's not 100%, one for one in what it does. There's a lot of things that the simulator doesn't care about, and it just kind of ignores those for a little while. Like the wait for start. Well, wait for start is there, but op mode is active isn't there because you don't stop it. Everything for the simulator is just autonomous. And you still normally care about wait for start. I think maybe, op mode is active. It's still there. Okay, great. I forgot. But not everything is there, and some options aren't there. But this simulator is fantastic in being able to sit down, learn something, because it has guided exercises. It's not just a sandbox. It's got guided exercises for you. And there's additional simulators that are coming down the pike. Virtual FTC is one of the other simulators. I think that's the one with the big R on it. There's a couple of other There's a couple of other simulators that are coming down the pike. This is the only one so far with guided exercises to be able to learn how to do timed execution, to be able to do execution for a certain number of rotations, or to use a manipulator, and then be able to do things, or use this drivetrain, then this drivetrain. This is a slide drive. It'll slide sideways and execute these different tasks in the program. or in the challenges. So I'm going to plug that. I'm not necessarily wearing my first hat. I'm wearing my mentor hat, saying this is fantastic. Even if wearing my first hat, this is still fantastic. Go and play with it, use it. The simulator only supports blocks. And there's no onbot Java or Java Android Studio for the simulator, but this is great for learning how to program a robot from scratch. Okay, that's my presentation here. Are there any
questions out there?
questions or anything I didn't cover? Probably should cover the next time I do this.
Hey, Danny, I'm going to come on audio here because my question is probably a little too long for me to type it out. But I asked this question in the previous presentation, and it's about using Java as opposed to blocks. And I asked, convince me why Java is better. And every time I ask this question, because I've asked this question several times, I always get, the kids who are doing Java, well, Java is better because I can, do X. What I'm expecting, the real answer I want is, well, what do you mean by better? Because for my kids, learning blocks is much, much more intuitive because they've had Scratch, they've had, the VEX programming, stuff like that. They get it. I switch to the little button that changes blocks into Java, and it's like I start teaching calculus to my Algebra 1 students.
Yeah.
It's entirely not intuitive. So my question is this: as an FTC coach, am I missing something, or am I denying my students something by not trying to push them towards Java or the next step?
Yeah, let me put my coach hat on really quick and say, it's all what you're comfortable with. Okay, what you're trying to do is you're trying to give your students the best experience. It's all about inspiration, right? And you can't be inspired if you can't program. My teams, when I came here to New Hampshire, I had previously had 6 years of FTC experience in Austin, Texas. I moved here to New Hampshire to get a job at First, and the very first, out of the gate, we got a programming mentor, and the programming mentor wanted to teach Java, and I was a little bit leery about that with middle school students. And the mentality was Java is what you're going to use in life, and so you should use Java. Push Java, make Java happen. But people who are learning, it's all about what they're comfortable with. And this, they can visualize the program before it runs. Java, it's really hard to visualize it. Some people are visual learners. Some people are, textual, readers reading. Some people just have to get their hands dirty. Some people not. It really is just what you're comfortable with. As far as I'm concerned, it's all syntax, because programming is programming is programming. It's all syntax, and the visual stuff is just syntax. I came from National Instruments, and we have this programming language called LabVIEW, and it's a graphical programming language, and everybody poos on LabVIEW. Oh, it's just that graphical thing. But there's some really hardcore, people in research who do some fantastic things with LabVIEW that would take them years to do in a traditional language. And there's pros and cons to everything, but literally it's what you're comfortable with, what they're comfortable with, and what's going to get them those successes to be inspired. And that's what's important.
Exactly. Because Margaret posted, no one programs professionally in Blockly in a job, which is, Danny just said, is not true, because LabVIEW is used professionally everywhere, and that's a blocks-based programming. So it's whatever you're comfortable with. I will echo what Margaret said about the AP Computer Science exam. It is Java, text-based Java, and doing that. So if you have any students that are taking AP Computer Science, weaning them towards the text-based version of Java would be a good way to go.
Yeah, that's great experience for taking those tests. Absolutely.
Margaret asks another question. What's the
Mhm.
easiest way to transfer old programs from the expansion hub to the control hub?
Yeah.
Oh, this is a good question.
Yeah. You pretty much have to go one by one. No. You can
No, no,
actually
no, no.
select them all, right? There's
No. The thing about it is in the expansion hub, your code is not on the expansion hub. It's on the phone.
Oh, you're right. It's on the phone.
Right.
Oh.
So all you got to
But-
do is download your
but-
code from your phone to the control hub,
Well, I was
and
about
then
to,
it's
yeah.
there.
So if you're using blocks and you're on that phone, go ahead and connect up the way you currently do, right? Can get your laptop to connect up to the phone. Okay, you don't need the Manny's completely right. You don't need the expansion hub for that. It is on your phone. So just get your laptop to connect to the phone via the web interface that you're normally using, and then in the blocks interface, let me see if I can't bring up this blocks interface. All you have to do is just check mark this top check box here. Check mark that top checkbox, and there's an option here that says download selected op mode. It's the one here at the very end. Download selected op mode, and it'll download every one of those op modes as individual files to your computer and your laptop, and then you can go into the control hub, and then you can say upload op mode, and then upload the ones that you want to send to your control hub. And so that's actually a pretty easy way of handling it.
Exactly.
All right.
All right.
Any other questions?
I was going to say
before?
this is a perfect time for maybe a break since Danny's back for the next session. So I'm going to go ahead and stop the recording.